to a lecture series on geobotanical indicators, lecture series on hydrogeology. In that, now what we are going to discuss about the groundwater exploration, how geobotanical indicators is likely to act as groundwater exploration or helping and to assess the groundwater in that particular area. Geobotany, it is nothing but the study of plants in relation to their geological habitat. Geobotanical indicators are either plant species or characteristics variations. Maybe with the help of plant species alone, we'll be able to identify sometimes the growth habit. If intensive vegetation is there, definitely there will be good amount of groundwater in that area. So it gives indirect indicators that are restricted to the distribution of rocks or soil of definite physical and chemical properties. Yes. This will give even sometimes quality of water where the sodium component is high or chloride component is high, then resistant to that chloride or sodium vegetation should be there. So like that, geobotanical indicators is helping us in assessing the groundwater in any particular area. Normally it's being used to locate and map groundwater. Not only groundwater, this geobotanical indicator helps us to assess saline deposit, hydrocarbons, rock types, and sometimes ores are also identified by using vegetation. Geobotanical methods of prospecting involve the use of vegetation for the identification of the nature and properties of the subsurface. These methods of prospecting are based on visual by looking how the distribution of vegetation is there. And why, even though if you have water, why vegetation is not much, and why its intense is not much. Again, it's all because of the dryness of this area and the chemistry of the rock type in that particular area leads that vegetation could not be able to grow fast, even though if you have water. Vegetation density variation, that is also very important. Vegetation density variation around a perennial stream in an area of fluctuating groundwater level. You see, the groundwater level will go, this is the highest groundwater level when the post monsoon season. After that, during dry season, the water level will go down because of pumping. And then this is, here also you will have to check the density of vegetation in this particular area. Once the density is high, then obviously you will expect good amount of groundwater. In temperature regions, the density of vegetation may indicate the depth of groundwater and the range of groundwater level fluctuation. Similarly, in springs, the water which comes into a spring, like the artesian water, there the density normally will be high. Vegetation around springs and ices as indicators of groundwater discharge in arid region. In most of the arid region, the plant that feed the water, that feed on the groundwater, stand in very sharp, so that you will be able to get good amount of vegetation in this area. So tree growth controlled by the presence of calcrete lenses. Sometimes what will happen, calcrete lenses will be there. It is not perched, like if we used to sometimes say. Because of this calcrete lenses, you'll be able to get the less density or the growth is very less in this area, very limited lateral groundwater flow. So that this leads in tropical and subtropical regions, the absence of trees or bushes may indicate that the presence of only bushes you'll be able to get. Calcrete horizons indicate of different soil conditions and weather zones. And vegetation supported by perennial spring. You see, you have a spring here. This is a perennial spring. The perennial spring which is coming, you can look at the perennial spring. This vegetation is supported by the perennial spring. So this also sometimes will be able to assess for the groundwater exploration. And geobotanical, normally geobotanical indicators like Phreatophyte, normally the vegetation will grow up to groundwater level. The root will go up to groundwater in the subsurface, or it is the Phreatophyte normally formed in the saturated zone region. And Halophyte, it's even grown over the water itself, and Xerophyte where there is no water. So there are normally three major types. Phreatophyte in the saturated zone, the root will go, and the surface water vegetation, and Xerophyte where there is no water, the plant will grow. Geobotanical, the first type, in the first type you just look at here, This is the groundwater level, and capillary fringe, that partly air and partly water. It means on the top of water level, you have partly, it will go up and down depending upon the recharge condition. So that variations, the root will go up to that and then takes the water for their growth. This type of vegetation is called phreatophyte. Plants that draw the required water directly from the zone of saturation indicate large storage of groundwater at shallow depth. Normally, this will not in deeper depth. Even the tree height also not much, but sometimes, if the tree height is very high, sometimes it indicates that the root goes down to take water deep. So it's partially 50%. Normally, we expect 50% of the height of the tree is the expected surface water zone in the subsurface. So it was pointed out by scientist Mainzer in 1923. He has coined a name called phreatophyte. It is normally taken the water from the zone of saturation. The term is obtained from two Greek roots and means a well plant. Such a plant is literally naturally well with the pumping equipment, lifting water and zone of saturation. This is the history of phreatophyte. And coming to the second type is xerotype. Xerotype plants that exist under arid condition by absorbing the soil moisture. Only the water which is present in the soil, it takes and it leaves. So it consumes only little amount of water. Intermediate or Vadose water indicate the scarcity of groundwater at shallow depth. The plant which are adapted to extreme economy of water, which depends on the rains that occur at long intervals for their scanty water supplies, and which during prolonged periods of drought maintain themselves in a nearly dominant conditions. These plants are also known as xerophytes. It is taken from a Greek word called dry plant. The third type is halophyte. You see, this is halophyte in a dry region and in a wet region. It is a salt tolerant plant. Both the figure which you can see, that this is backwater and this is the soil itself looks like high enrichment of salt in condition. So a salt tolerant plant that grows in soil or water of high salinity coming into contact with saline water through its roots or by salt spray, such as saline semi-deserts, mangrove swamps, marshes and sloughs and seashores. So are the examples that where the plant are present in this area are halotype. Halotype indicate the presence of shallow brackish water and saline groundwater. Mangroves and all coming under this type of halotype. So with this, how geobotanical indicators is helping a hydrogeologist to locate the groundwater is discussed in brief. So thank you very much.